All right, we're on chapter 4 of our first semester final review. So for 14a, it says list 3 segments of a triangle that will create a triangle and 3 segments that will not. And what's going to happen here is we need to have that the longest side is less than the sum of the other 2 sides. So as long as that holds up, it's going to form a triangle. So if I picked 3 numbers like 12, 10, and 9, 12 is less than 10 plus 9, so that's going to work every single time. Now, one that would not work is, let's go with 12, 6, and 5, because 12 is not less than 6 plus 5. 12 is not less than 11, so that's false. Got to be careful though here. If it was 12, 6, and 6, that would still not work because 12 is not less than 12, it is equal. So the sum has to add up to be bigger. They just have to be big enough to reach to close in the triangle. So really any set of numbers work. It's focusing on this rule though, right here. Now, 15 is one we have to be careful for because a lot of students go to 15 and want to set them equal. We have to use a little common sense. If I have a side inside the triangle and this side on the outside, they are not equal. And I know most of the time we say the diagrams are not to scale and all those things, but that's really so you're not taking out a compass or a ruler and measuring. But I can see that BC is a lot bigger than DE. Don't set them equal. This is what we call a midsegment. Because it is a midsegment, it is half the length of the side. So I could either double this to set it equal to 3n plus 2, or take half of 3n plus 2 and set it equal to n plus 5. In this case, it's easier to double n plus 5. So then I get 2n plus 10 equals 3n plus 2. Subtract 2n, subtract 2, and I get n equals 8. Now I can go back and check this, and I have here, this is 13, and this is 26, and look, it is half of the side, so it worked. Now B, this is looking at angle bisectors. Angle bisector is equidistant from the sides. That's the rule, but it's really setting these equal. You could have also taken this back to last chapter, chapter 3, and if I reflect this over, these 2 triangles are congruent as well, so it's really matching corresponding parts. So if I add over n, if I subtract 3, I get n equals 4. For C, again, congruent triangles, it's also perpendicular bisectors are equidistant from the point here. This T is equidistant to L and D. That's the rule, but it's really setting them equal to solve. Do not use the 8n minus 13. It is a distractor. Subtract 5n, add 3, and I get n equals 7. Now for 16, it's looking at triangle inequality, the fact we can write out the order comparing the sides. I know that the smallest side is PQ, then it's QR, and PR. So in terms of angles from smallest to largest, the smallest is opposite PQ. Well, it's the other letter, so it's angle R. Next is angle P, and the largest is angle Q. So when I look at these inequalities, I like to go through and use the fact of what's the biggest and what's the smallest. So for example, I know Q is the biggest angle. If it is the biggest angle, it is not smaller than anything. So everything that says Q is bigger could work. Well, right here, it says Q is less than R. But if Q is the biggest angle, it's not possible for it to be less than R. So that one is false. Now, this one is good, this one is good because Q is bigger than both P, angle P, and that's just 2 different ways it's written. I also know angle R is the smallest, so anything that says R is less than something works, which is here and here. So it's not so much writing them and trying to figure it out looking at these individually. If I can write the list, then you can just match by thinking what's the biggest, what's the smallest. Okay, 17. We are going to look at what we have for information and then use that to help us in the table below. So D is a point on side ABC. I got that. AB is congruent to AC. So right here and here. BAD is congruent to CAD. So that's right here and right here. Now, I also have reflexive property, and that is important because that gives us angle side angle congruence. Try that again. Side angle side congruence which also tells us that all corresponding parts will also be congruent. So I'm going to change colors here. So these are what I know, and then I bring this in, so I now have these angles congruent, these sides congruent, and then since the angles at D are congruent, they're actually also going to be right angles because congruent supplementary angles are right angles. All right, so now let's go through and look. AD perpendicular to BC. That is true for all. That works because I have congruent triangles, the corresponding parts match. Angle ABD, which is right here, is less than BAD. I don't really know the measurements, so it could be true for some, it could not. It really depends what the angle is. I don't know, so we'll go true for some. It's possible. It really just depends on the value. This congruence doesn't really apply to the angle value, so it works for some. Measure of angle ACB, which is right here, is half of ABD. Now this, we almost think like the last one, true for some, but this one is false because these two angles are congruent because they're corresponding in our congruent triangle. So that's not true for any because it's not half, they're equal. Last, BD is equal to half of BC. That one is true for all because this is a midpoint right here. We know these two segments are congruent, so the whole thing is double, the smaller piece. Now we go on to 18. We're going to graph our triangles. I have A here, I have B and C. So find and label the points for coordinates D, which is the midpoint of AC, and E, the midpoints of CB. So let's start with AC. So I need the midpoint. Well, I know A is at -5, -2, and C is 3, -4. So the midpoint of D, I'm going to use midpoint formula, which is adding the x's, dividing by 2. So -5 plus 3 is -2. Divided by 2, and then -2 and -4 is -6 over 2, so this comes out to be -1, -3, which we go to graph and actually hits on the line. It should. It's a midpoint. It's on the line. Now we also could have kind of cheated on this and said, well, I went down 2 over 6 or over 8, so if you do half of that, it does still show up. For E, I'm going to add, I want it on CB, so I'm going to add these two. I get 2, -1 and 3 is 2, divided by 2 is 1, and then 6 plus -4 is 2, divided by 1 is 1, which also puts E right there. And this gives me a line. I'm going to draw that one. That is a midsegment. That is midsegment ED. So I need to first show that DE is parallel to AB. So here we're going to go slope of AB. Slope is again the change in y over the change in x. From A to B, my change in y is it went up 8. My change in x is it went over 4. So my slope is 2. My slope for DE, again change in y, change in x, is this time I went up 4 over 2. And that comes out to be 2. So I know that the slopes are the same or equal. So lines are parallel. Now I need to check the length, and I need to use distance formula. So my distance formula for DE, let's start with that one. Distance formula is the change in x squared plus the change in y squared inside the square root. It's like Pythagorean theorem on a graph. So my change in x squared is it went over 2, so 2 squared. Change in y is it went up 4. So this is going to be 4 plus 16, or the square root of 20. Now, AB, the change in x was 4. The change in y was 8, and I did these up at the slope. So I got 16 plus 64, and that is the square root of 80. Now, we haven't done much with simplifying radicals in the regular math too. In the honors class we have. So if we simplified, let's just take the square root on a calculator. So if I did the square root of 20, we get it's about 4.47, and then the square root of 80 is about 8.94. I do see that it is double AB, or it's half for DE. And we could also simplify this. Square root of 20 is 4 times 5, so that becomes 2 root 5. And then the square root of 80 becomes 4 root 5 if you can simplify radicals. And again, we can see that it does work out for that length. Now for 19, E is the midpoint of RS, F is the midpoint of RT. We need to show they're parallel by their slopes. So I'm going to start with the slope of ST. So the change in Y over the change in X, we have 2n minus 2t, my Y's, and the X is 2m minus 2s. Now what I'm going to do is I'm going to factor out a 2 from both of those. And that simplifies, the 2 over 2 is just 1, to be n minus t over m minus s. Now, slope of EF, change in y is n minus t, change in x is m minus s, and this comes out to be the same value. So I had to reduce the first one, but they simplify down to be the same thing. So their slopes are equal, so they are parallel lines in the coordinate proof. All right, last one for chapter 4. Jim claims that the triangles are congruent. Choose which would not be enough information to prove the triangles are congruent. So AB parallel to BC, AB parallel to DC. Before I do that, I'm going to mark what I know. I know I got reflexive property. So that is guaranteed to be there. So if I did that, and I went and looked at option A, and I'm just going to kind of draw them on a separate triangle so I don't have to keep going back to the same one. If these two sides are parallel, I have alternate interior angles here, and then if these two are parallel, I have them here. This would work and be an angle side angle. So that would check out, that one is true. ABC is a rotation of CDA. If I took ABC and rotated it, let's say around this point right here of 180 degrees and turned it, a rotation preserves congruency, so they would be congruent, so that one is true. AD congruent to BC. Let's redraw what I got. If AD is congruent to BC and AB is congruent to DC, I have side, side, side. That holds up. That is going to be congruent. Lastly, AD, let's draw it over here. AD congruent to AC, congruent to CB. Well, that one doesn't work really because I don't have all three sets of sides. I don't have any angles, and all that really tells me is I have some isosceles triangles here, and isosceles triangles don't guarantee congruence. I could have something that looks like this. Now we look at this diagram, and these three sides all kind of look the same. They're all isosceles triangles, but they're not congruent triangles. So that one is the one that's going to be a false. It does not give the right amount of information.